Hello everyone. Today I would like to provide you with the demonstration number 2 as a series I provided you under the week 3. There was a in-class exercise files. It was including 2 JPEGs. The first demonstration I provided you was discussing the solution for this problem, and I taught you how to do the R-value calculation. However, when the building is including different walls and windows and all that, it's not always the R-value you learned on the first demonstration is the solution for the total R-value. So this house, which it has a height of 8 foot to the underside of the gypsum wallboard, and door and window with the different R values, each in different scenarios, is the matter of question at this point. And with this demonstration, you would learn how to look into solving a total R value for a wall. Stay tuned with me. The objective for this conversation today is giving you the solution for the exercise. So that exercise is including, this session is including apply the lesson learned in R-value calculation, which was a demonstration number 1, to gain the wall total R-value calculation. See how we can use that. There is a window to wall ratio, WWR is a terminology that today you will learn about that a little bit more. And then we are going to compare the different scenarios to achieve the optimum solution for a design. This is a very useful demonstration for you to learn how to do the total R value. Stay with me. Here is the solution. First of all, what is the question? You need to learn to be critical to understanding the question comes at you. Here is a very simple house as an example. I drew that a sketch on the whiteboard in one of the lovely classes at a CAT building at NAIT, but I took a photo of that a couple of years ago when I was teaching this, and I decided to provide you with this tutorial because of the online teaching, I don't have access to you and you don't have access to me, and we have to find a solution to give you the way of solving the problem, and I can show you here today. First of all, let's understand what is the question. What is the information provided in these sketches? There are some elevations provided. This is the main elevation. Here is the side elevations. So both side of this small house has the same elevation with the 6 foot square window with different R values. And here is the back elevation. This is a porch coming out, and there's a patio coming a couple of steps down and goes to the backyard. Frontage of this house is 14 foot. Here is the floor. Below the floor is a rim board and the foundation wall. We don't discuss that at this point. What we discuss is from this line, which is a finished floor for the main floor, to the underside of the gypsum wallboard. We understand the height is 9 foot using the studs. However, here we are talking about the underside of the gypsum wallboard, and that's what we are looking for in this exercise. The underside of the gypsum wallboard ceiling is base for the calculation, as I mentioned. The list of all available data provided in the sketch, and then we are going to do the calculation for the R value for the first by assigning the wall R value as 19, and then we will change that to R value as 26. So imagine different scenarios. If the scenario number 1, the R value is 19, and if the R value is 26, then what would be the results of R value for this elevation? And then we are going to compare the answers together to see how we can learn from it. And if we change the R value on the components on the wall, how we will be enhancing the R value, total R value of the building. Here are the formulas we are going to use for this calculation. We all know R is the reverse of U value, and obviously U value is the reverse number of the R value. This is the key formula that we always use it. U0 is equal to A1 U1 plus A2 U2 plus A3 U3 and so on and so forth, as we mentioned in the previous demonstration, over the total area of the wall. If we want, we can have the same formula to directly find the R value. Yet, I always prefer to go with this formula. It's easier. This looks a little bit more complicated, and I normally use this one, even building code. And the Canadian Home Builders Association uses that U value formula. Let's take a look into it. Okay, so here is the total R value exercise solution. In the front elevation, when you take a look at the sketches provided, the width of the house is 14 foot. The height is 8 foot. This is the total frontage of the house, 112 foot square. However, the front wall area is the total area of the front minus 20 foot square for the main door and 20 foot square for the window. So the wall area is only 72 foot square. For the first scenario, we'll take a look at R19. When we reverse that R19 to U value, that's almost this number. Because it's so much a fraction, I round it in a third digit after the fraction. There is a front door, which is a 20 foot square. Once we will go with the R5, and then we'll do the scenario 2 for R7. For this exercise, at this point, we use the first scenario R5. How to use the U value, 1 over 5, which is going to be 0.2. For the window, the R value for window is lower. So it's either R1 or R3. When we use R1, the U value for the window is 0.5, and if we use R3, that's going to be higher. In this scenario, let's use that yellow highlighted numbers. When we put them in this formula, the 72 area is going to be times the U value. Here is the area, here is the U value, and then here is the area 20, and here is the U value, and then the area is 20 foot, and here is the U value. Doing this calculation over the total area of the frontage, the U value is going to be 17.816 over 112. Almost this U value will be that number. When we reverse that, this becomes 6.285. Normally, we have to round the numbers. There is no fraction on on R values. So because it's a very closer to 6, and this is below 6.5, then we'll go with R6. If it was above 0.5, let's say 6.6, we would have used R7. But in this case, this is a scenario that we accept. First scenario, main elevation, R value is equal to 6. Let's take a look at the scenario number 2 at this point. Now, in this scenario, we have a substantial addition to the R value for the wall. Here is the U value for that R26. I put this nomenclature here just to show you this is a approximate number. We won't go to 3 digits of fraction in calculations, but just to give you a heads up, this is rounded. And the R value for the door is become 7, which is a 0.14, and the R value for the window went to 3. By enhancing all that, 2 in here, 2 in there, and then about, let's say, 5 in, 6 in here, 7 in here, we are going to calculate the total R value, what the numbers provided. A1, U1, so A1 is 72, U1 is 040, and then 20 for the door to the U value 0.14, and the total R of foot square for the window times the U value for the window become 11.66 over 112, which is going to be U value of 0.1041, which is the R value 9.6. As I mentioned, we are going to round them. So when we round this up, it's going to be almost 10. By comparison, when you look at this equation, the first scenario, the total R value for the front elevation, for the main elevation, was R6. However, we changed the R value for the wall from 19 to 26, and the doors and windows added a little bit more, from 5 to 7 for door, and for window from 1 to 3. But overall, R value enhanced on the 4 number. At this point, I would like to bring this up and draw your attention to window wall ratio. So the higher the glass area, the lower the total R value, because the glass has a lower R value. Smaller the windows will help the overall performance of the total building's R value. So having lots of glass in the building does not help the R value calculation, the overall performance of R value for the building. So the consumption of energy is going to be higher. Based on what you learn, I would like to invite you to perform the total R value calculation for the other elevations provided on the sketch. So for the side elevations and back elevation, please do the same calculation as you learn so far, and then compare the answers. Here, based on the document provided by the Canadian Home Builders Association in Alberta, obviously, we provided this document to you in PDF on Moodle. Take a look into different wall components and building components and roof components. See if, let's say, having a rim joist in Alberta, when your building has the HRV, 16.9 is the minimum R value calculation for that only rim boards area. You need to remember all that. If you don't remember what the rim boards are, or what is the floor over the unheated space, take a look into slide number 10, and all of them here is the, let's say, floor over unheated space. This protrude out. Take a look at this sketch and decode every jargon here and all the components provided in this sketch to understand exactly what these terminologies are about. And we are in 7A zone in Alberta, and here is for the building with HRV, and here is the numbers under that column for the building which has not installed a HRV. That's why it gives us a freedom to have a lower R value. As you can see, for the windows and doors, here it says page 27. Here is the page 27, as I mentioned it there. Normally doors and windows in Alberta, in Edmonton and Calgary, here is the maximum USI value. USI value is a metric type of a U value. It's 1.6, and the minimum energy rating for that, it should be 25. So make sure when you take a look into the specification for the windows and doors, have those numbers at the back of your head. Hopefully by having this demonstration you learn something new, and please feel free to ask your questions. Whenever you have any questions, just email me and I will get back to you as soon as I can. Thank you very much for your time. Enjoy the rest of your day. Bye for now.